Hello! In this video, we're going to look at how Garden can provision your infrastructure across multiple environments. Garden is a development tool for distributed systems, or simply microservices, that takes care of building, deploying, and testing your entire stack. In this demo, we'll be spinning up a GKE cluster on Google Cloud Platform and provisioning a Cloud SQL database using the Garden Terraform plugin. We'll deploy our sample application to the cluster and demonstrate how we can connect to different databases depending on the environment. We're going to show how the project is configured, the commands and workflows for provisioning the infrastructure and developing the application on a remote cluster, and finally deploying it to a staging environment. Now, in front of me I have the Garden dashboard, the project code, and a terminal. In the dashboard we can see that the project has a single backend service and two databases that we deploy depending on the environment. Garden is pluggable, and here we're using the Kubernetes plugin with the container and Helm module types, and the Terraform plugin and corresponding module type. We use the Helm module type for deploying a Postgres database for a development environment that we can destroy and recreate as we see fit, and the Terraform module type for provisioning a persistent Cloud SQL database for our staging environment. We're currently in the dev environment, so the staging database is disabled. And if we look at the Google Cloud Platform console, we'll notice that there are no existing Kubernetes clusters in this project. Now, in the terminal, we can see the code structure. The project has a single backend service written in Node.js, and the infrastructure is defined with Terraform files in the infra directory. You'll notice there are separate directories for the cluster and for the databases. In the editor, we see the project level Garden.yaml configuration file. This is where we define project-wide configuration, such as global variables, and register the providers we want to use. In this case, the Kubernetes and Terraform providers. Now, the variables defined in the variable section get passed down to the Terraform config files. Here we're deploying our staging environment to the same cluster, but a different namespace to keep things simple. If we wanted a separate GCP project for our staging environment, we could simply override the default, like so. Now, let's imagine this is my first day on the job. I've been added to the Google Cloud Platform project, I've just cloned the repo, and I have Garden installed. We've already seen that no infrastructure has been provisioned for this project. So, let's go ahead and fix that by running Garden plugins Kubernetes cluster init. Here we're telling Garden to use the Kubernetes plugin to initialize our cluster. We've also configured the project so that if our infrastructure is not ready, Garden will ask the Terraform plugin to apply the relevant Terraform files. Once the Terraform plugin returns, the Kubernetes plugin will continue initializing the cluster and setting up the system services. In this case, we're using the in-cluster build mode, which means Garden will build the images remotely. This means that I neither have Docker nor Kubernetes running on my laptop. All in all, it takes about 7 or 8 minutes to create the cluster and then deploy the system services. In the Google Cloud console, we can see that the cluster has been created and the Garden system workloads have been deployed. Now, before we get to work, let's take a quick look back at the dashboard. On the stack graph page, we can see the graph representation of my stack. This is how Garden knows which parts of my system to update on changes. There are two build tasks that can run in parallel in this environment. And here I can see the deploy step for the database, which of course depends on the build, and the deploy step for the backend, which depends on the backend build, the database deploy, and the database populate task. So when I run Garden deploy, it will make sure all these steps happen in the right sequence and parallelize those that it can. At this point, let's take a quick break. Alright, so to briefly recap, we're looking at an end-to-end development workflow in Kubernetes using Garden and the Garden Terraform plugin. So far, we ran a command to provision the infrastructure and looked at the project structure and stack graph in the dashboard. I also went ahead and added the external IP to the cluster to my DNS provider so we can see the backend output in a browser. So, without further ado, I'll now run the Garden dev command. This command does it all: builds, deploys, run tasks, and tests. The hot reload flag tells Garden to hot reload the backend service. That means that instead of rebuilding and redeploying the service on changes, Garden will sync the code into a running container. You can see as my stack is coming up that I already deployed it, both to shave some seconds off this video and to show that Garden is smart and doesn't rebuild or redeploy services unless they have changed. Garden is now watching my code for changes, and I can get to work. Here we're looking at the backend service. It's a simple web server written in Node.js using the Express library. It has two endpoints, one that just returns OK, and another returns an entry from the users table in the database we deployed when running the deb command. Here we can see the task that we ran for the database module, an init task and a populate task. You can also view the endpoints inline from the dashboard. Here's the one that returns OK, and here's the one that returns the database entry. Now, if I, for example, add an exclamation mark here, you'll notice that Garden hot reloads to service. The first one is a little slower, but subsequent hot reloads are quite fast. Now let's add some more exclamation marks to let people know that we mean business. This time the hot reload is faster and the changes are visible immediately in the browser. Sure, let's uppercase this. Again, we can see the changes immediately. And I'd just like to point out again that all this is running in the remote cluster we created earlier. And still, the code updates almost immediately, so it makes for a very fast feedback loop. In fact, it feels just like development locally, except my laptop is not having a meltdown from running Kubernetes, Docker, and my entire stack. Now, at the beginning of this video, we said we want to deploy a project to a staging environment as well. But of course, we need to run tests before we do that. So let's open test.js. And here you'll see that I've already written the test. It's very simple. It just calls the hello endpoint and checks for the response. Because the backend depends on the database, and because we'll let the test depend on the backend, we can be certain that it won't run until the database is ready. Now let's open the stack graph page, and then go to the Garden.yaml configuration file for the backend module. I've already added the test. We just need to uncomment this to enable it. As I do that, you can see the Garden response to the changes. It needs to rebuild and redeploy the backend since the configuration has changed. And this time, Garden will also run the test. Now, the test fails and we can see the error in both the terminal and the dashboard. Basically, the test wasn't expecting this aggressive a response. But you'll notice that even though all of this is running remotely, we get the feedback almost right away. For larger projects with multiple services, you would usually have to wait until CI to see this kind of integration test breaking. But here we get the feedback as we develop and we can fix the issue right away. So let's go ahead and do that and fix our test. Now, once again, Garden responds right away. And this time the test passes. So now we should be all set for deploying to our staging environment. Like I mentioned earlier, we're using a Postgres Helm chart in development that we can easily destroy and recreate. For staging, however, we want to use a persistent cloud database. Since this is supposed to be our first day on the job and nothing has been set up, we'll need to ask Garden to provision that for us as well. You can also see in my Google Cloud Platform console that there's nothing there. So this time we want to run the garden deploy --env staging command. As you can see in the stack graph, the dev database and associated tasks are now disabled. Instead, we create the staging database via the Terraform plugin and have the backend depend on it. In subsequent deploys to staging, the database will not be created. Here we're running the command from our terminal, but this is also very useful in CI. You can imagine a CI job that runs garden test and, on passing, runs garden deploy staging, ensuring all infrastructure is up to date along the way. And notice also that since Garden already knows how to build, test, and deploy our stack across all our environments, the CI pipeline really just boils down to a handful of commands. What's more, Garden will reuse test and build caches, making for an extremely efficient pipeline. Now the deployment is complete, and if we go back to the Google Cloud console, we'll see that the Cloud SQL database instance is already there. And so, for the very last step, we'll use Garden to exec into the backend module in the staging environment, and from there connect to the database. The database is a private IP and is running on the same network as our cluster, so we can connect to it directly from our backend service. Garden can use the outputs from the Terraform module and add them as environment variables to the backend. So no matter what environment we're in, the container will always have these variables set. So here we're inside the running container in a remote cluster. Using PSQL, we can connect to the Cloud SQL database. You can see that we're using the environment variables that Garden has set. And now we're inside the Postgres shell in the Cloud SQL database instance. And we can create our user table and add an entry to the table, a user called staging. And for the grand finale, we'll go back to the hello endpoint. And sure enough, there's the data from our staging database. So I really hope you've enjoyed this video. I highly encourage you to check out our other videos for more examples of how Garden works. Everything I showed you today is open source and available on github.com/garden-io/garden. It's easy to get started if you want to give it a spin. And if you have any question, you can always find us in the Garden channel on the Kubernetes Slack. We would love to hear from you. Thank you.